Hello and welcome to Pandora RMM. In today's video, we will look at RMM, what it is, how to configure the environment to enable it, and how to use it. First, we should get an idea about what RMM is. Its name comes from the acronym for Remote Monitoring and Management and allows us, as the name suggests, to create executions from Pandora RMM console itself that may be executed at a certain time or periodically as a cron on remote agents with RMM enabled. You may find three main components: RMM server, RMM agent, and RMM tentacle service. The way it works in a somewhat summarized way would be as follows. The RMM agent contacts the RMM server at periodic intervals to send two different file types through Tentacle. These two types of files are keep alive and data. .keep alive files are sent to all RMM agent intervals, which by default are 30 seconds, and will let the server know that they're awake or available. On the other hand, .data files will be sent only when there has been some previous execution in the RMM agent, so that an interval may go by without having any execution, and therefore only the keep alive file would be sent. As mentioned, these files are transmitted through Tentacle and specifically are received by the RMM server in its RMM-specific Tentacle process, and are stored in the path indicated in Pandora server configuration file, which we will see later in the enabling and configuration section. Within this path, you may find several folders, and for this specific case, you will have folders for the extensions, data, and keep alive, which will be stored and will later be read and interpreted by Pandora server. Next, we will see how to configure and enable RMM. First, enable the dedicated server for RMM on Pandora server. For that, go to the server configuration file. If remote configuration is enabled, you may do so by clicking on the server information present in the upper corner of the console to the right, and in the first server listed, open the option for Manage Server Conf that you may find in the Operations column. In case of not having remote configuration, edit it from the terminal. The default path is etc pandora_server.conf. Now within the file, uncomment the line RMM server 1, which is commented by default. You may see a couple of additional parameters, which are RMM server_threads and RMM dir. This will allow you to choose the number of threads intended for the execution of the RMM server and indicate the local directory of the machine to be used for data exchange with RMM agents accordingly. Once the changes have been made, save them, and you may restart the server manually so that they are applied. Then keep in mind to have the RMM-specific Tentacle process running on the server. You may check it by running the following command in the terminal: ps aux grep tentacle grep vgrep. You should see at least two processes. The one that matters to us will be the one using the file etc tentacle_rmm.conf. This process should start automatically following the execution of the RMM server. Once that is running, the server part will be ready. Next, configure the relevant agents to make use of RMM. This may be done in both Linux and Windows software agents, and for that, go likewise to their corresponding configuration files. Remember that if you have remote configuration enabled, you may do so from the web console. For that, from Management, Resources, Manage Agents, you may access the editing of the configuration file of the relevant agent and then modify the line RMM_enabled by replacing 0 by 1. You may see other parameters, like RMM_interval, which will determine how often RMM agents check whether there are executions queued for themselves and execute them. It is set to 30 seconds by default. Then there's RMM_server, which will indicate the IP address or DNS name of the RMM server. By default, this line will be commented and will use the same address or DNS name that we indicate in the server_IP parameter, although you may indicate a different address or name if the RMM server is on a different machine than that of Pandora server of the software agent. Next, there's RMM port, which will indicate the port that will be used for Tentacle connections, and it must be the same one that the server is using. By default, it will be 4.11.23. Then you have RMM_temp, which will indicate the local directory for temporary files related to RMM executions. It will read /tmp by default. As for RMM_extra_ops, this parameter will indicate the password or key needed to establish the connection using Tentacle for RMM runs. It is configured by default, but if you need it, you may find it in the file etc tentacle_rmm.conf of the server in the parameter password. And finally, RMM_debug. It will indicate the local directory where the logs or debug tries will be stored. Once we're clear about what each parameter is for and you have it configured, you may save the data and wait for the next agent interval for the changes to take effect, or manually restart the agent. Afterwards, you should be able to see the processes of Pandora_RMM_agent by running the command ps aux grep rmm grep v grep. Once at this point, the agent should be contacting the RMM server and everything will be ready to go. But first, let's go over the views you may find. If you access the console and go to the View Management RMM heatmap, you will see the agent listed in blue. In addition, there will be a legend that will tell you what each color means. The blue we are looking at would indicate that the RMM agent contacted and it's active. But since it has not performed any action, it does not have a state yet. Here you will see all the RMM agents that contacted the server, and you may use filters to limit or specify a search either by name, connection status, or status. If we look at the top right, we will see more flaps with the other available views. The next one on the left will be the agent list view, whereas in the heatmap view you will be able to see the registered RMM agents and the same filters, but you will have other data such as the name of the agent, its IP address, the operating system, its version and description if it has it. In the Actions section, you will have the options to delete said RMM agent or create executions. These actions may also be executed in bulk using the checkboxes that you see on the left side of the table. The power of creating executions will be seen later. The next view you may find is the Schedules view. Here you may see the schedule executions. This is one of the two types of executions available and that you will see in more detail next. Continuing with the following tab, here you may find the Queue view. Here you will see all the queued executions in the environment, along with a series of data that will help you identify them. The data displayed is the name of the task or execution, the agent that will be responsible for executing it, which script it will use, its current status, the last time the execution was queued, the step it is in if it was executed, output and error messages, and the date of its last execution. There's also a series of filters that will help us limit the data displayed, having fields such as tree search that will search in the columns of task name, agent, script, step, output, and error. Other filters are the list of scripts, status, last queue, and step. Finally, in the table, there will be the actions to open in detail or delete said execution from the queue. The next view there is that of scripts. Here you may see all the scripts registered in the environment as well as information about them and the possibility of creating new scripts, editing existing ones, or deleting the ones you wish. When creating scripts, the form will be the same as when editing them. If you click on New Script, you will see it. You may give it a name, a description, indicate operating system in which it will be used or supported, in addition to the version of said OS. This is only for organizational purposes as it will not work as a limitation when assigning executions to RMM agents. Also indicate a group to which said script will belong to, and next to it we will see a token called Notify before executing. If you open the tooltip, you will see a message that indicates that if enabled, the agent that will carry out an execution with this script will report a status of success prior to the actual execution of the script. This is useful in cases where the RMM agent process would be stopped and it would be impossible to correctly report the execution data after the actual execution. This correct state will be represented in the list of queues, but in a different way from the correct state of an actual or finished execution, so that it can be easily identified. The status column will show a green box with white stripes or lines. The following thing you find in the script form is the input section. This section will later allow you to customize the script a little more. If you click on Add Input, you will see that you may give it a name, choose a type between string and resource, indicate a tip or help on set input, and the macro value that set input will have, which by default will be auto-configured. The difference between the string and resource types is that with a string input, when creating an execution, you may manually indicate the value of set input, and as its name indicates, it would be a text or character string. For example, SSHD referring to the SSH process. With resource inputs, when creating an execution, you will be able to choose from the list of resources the one you see fit. We will discuss this a little more in the next view. It should be noted that inputs are not required for scripting. Once you configure the input section, the following will be the configuration of the script as such. There are 3 types of scripts: precondition script, and post script. Out of these 3 types, only the one in the middle, the script, will be required. The other 2 are optional. The configuration structure is the same in all 3 types. You may indicate which parameters each script may use in the parameters field by indicating each parameter in macro format. This will be the macros we saw in the input section. If you create an input with macro test, indicate it in the parameters section. In the interpreter section, you may indicate which command interpreter will be used for script execution. Some may be used, such as bash, python, perl, etc. Next, you will have the file extension part to indicate the extension of the script file, and finally the code part, where to enter the code of the script itself. If you look at the default scripts, you may see the configuration they have. In the example bash script, for example, you may see the configuration it has, since it is a script that has a precondition script, and post script. Finally, the last view is that of resources. Here you may see the resources that you uploaded, and later they may be used in the executions you create. To add resources, just select the relevant file from the file browser that opens when you click on Select a File, and indicate a short name that will work as a unique identifier of the resource. In case you wish to upload a resource using a short name that already exists, you will be asked if you wish to update the previous resource. These resources will be stored, as well as the Keep Alive and Data folders, in the RMM directory indicated in the server configuration file under the name of res. In the console, it will be displayed as follows. You will see the real name of the uploaded resource, the short name you gave it, and the date the resource was created. In addition, there is the option to individually or massively delete these resources. As we indicated in the scripting section, these resources are those that may be used as inputs in the scripts should you indicate that the type of the input is resource. Once you have seen all the available tabs at a single glance, you will have to see one last view before moving on to execution creation. This view is that of agent details. It is individual to each agent and is accessible from the following views: queues, schedule, agent list, and heatmap, by clicking on the agent name. In this view, you may see the list of executions carried out and queued, in addition to the executions schedule at the bottom. There will be a series of filters for each section, and it should be noted that the executions shown will be grouped by task name and executed script, so that if there are different executions with the same name but different script, or the other way around, the execution history will not be combined. But in case of having different executions with the same script and execution name, you will be able to see the history of all of them by clicking on the corresponding icon in the Actions column. And finally, after having analyzed these views, we just need to cover execution creation. There are several ways to do this. From the agent list view, you may select several agents with the checkboxes and click on New Execution in bulk, so that you may add the same execution in different agents quickly, or from the agent detail view of a specific agent by clicking on New Execution. Either way, the execution creation form will be the same. With the first selector, you may filter the script by operating system, and with the second, choose the script you wish to use. Afterwards, indicate a name for the execution or task and the type of program, which, as we discussed, may belong to the type only once or schedule, where you must indicate in a cron format when the execution of said task will be carried out. In the case of choosing only once, the execution will be queued as soon as it is created. On the other hand, if you choose a schedule, the execution will appear in the schedule view, but will not appear queued until the specified time range is specified for it. Finally, configure or edit if required the parameters section for the script. These fields are determined by the configuration of each script. As we saw in its creation, you may add as many inputs as you wish, and they will be the ones that appear here. Now, if it were string, you may type in or indicate a string of characters, and if it were resource, you may select any resource from the drop-down, if you have RMM resources in the environment. Finally, click Confirm to finish creating the execution. For the purposes of this video, apart from creating the execution shown of type only once, I created a similar one of schedule type to display in the schedules view. If you access this view, you may see the name of the task, the name of the agent it belongs to, what script it uses, and its execution schedule in Chrome format. From this view, you may edit this schedule. If you switch to the queue view, you will see that you only have the only once execution. This is because you are not currently within the execution time of the scheduled task, and therefore its executions are not added to the queue. In addition, you may see that set queued execution was executed and it has a status color other than blue. In this case, you may see that the execution status is correct with a green color, and you will have information about the step where it ended and the output message provided by said execution, in addition to the date on which it was executed. And that was it for today's video. Don't forget it. If you liked the video, smile, give it a thumbs up, and subscribe. Any suggestions, questions, or ideas, please leave them in the comments below. Remember that if you're interested in trying Pandora RMM Enterprise, you may contact us to get a free 30-day trial. Thank you very much for your time, and we hope to see you on social media and in future learning videos.